In this video, we're going to cover how to set up a failover interface for the OES driver interfaces. And this would be supported for Modbus, OPC UA, even classic OPC servers, connections to Siemens S7, Allen Bradley controllers, and even to IoT gateway solutions like MQTT, AWS, Azure, and even receiving data from MTConnect streams. I'm going to show you how to set this up, and I'm also going to demonstrate it using a system using a Modbus emulator and also OAS running on a Raspberry Pi 4. And that will be running the Modbus slave interface, so we can basically use it as a Modbus slave device as a primary interface, and then the simulator will be the backup interface. And so what we'll do is we'll disconnect the network cable from the Raspberry Pi to emulate the failover condition. So first, let's dive into setting up the Raspberry Pi to run as a Modbus slave device. I'm going to start up the Configure OAS application, and I'm going to go to Configure Drivers, and I'm going to select the IP address of the Raspberry Pi. There, I'm just going to give that driver interface name something unique. I'll just put it in as Modbus. And in this type, we're going to set it up as a slave, so it will run as a Modbus slave. I'm going to use the IP address of the Raspberry Pi, and I'm going to change the port here. So it's 502 seems to be used for exclusive use on Raspberry Pi, so I'm going to put up something that is unique that OAS can use, and we'll set that to 58,000. So we'll add that. The next thing we'll do is we'll set up one or more tags on the Raspberry Pi to run as the Modbus slave. I'll just put a group so that I can organize them. And then we'll select that group and right-click on it to select Add Tag. And I'll just put HR1 for holding register 1. We'll make it pretty simple to set it up as a data type of an integer and the data source of Modbus. We'll take the defaults of holding register 1. We'll select Apply Changes, and we see that we have good quality there. Now that's just we're emulating the Modbus slave, so we don't really know if we have any master communicating to us yet. But let's set up some simulation data using the data route feature built into OAS. So on the Raspberry Pi, I'm going to go to the built-in ramp tag and change the simulation rate to 100 milliseconds. And then I'm going to go to the target tab, and I'm going to enable the target to browse to that tag that we just added. So that was under Modbus slave, and there's the tag itself. We'll select Apply Changes. Now, just to see that in action, if we go back to the tag we're writing to, under the Value tab, we see that value of the ramp tag being written to the Modbus slave holding register here every 100 milliseconds. Now we're ready to set up our test using the Windows operating system. So let me just show you how that is configured. So what we have is the Windows server is going to be bringing in data both from a emulator on the right and the Raspberry Pi that we just set up on the left. Now with the OAS engine running on my local Windows system, I'm going to choose localhost. And here we have the demo tags. I'm going to go to Configure Drivers also on my local system. And this time we're going to make up a Modbus master interface. And the original IP address, that comes from our Raspberry Pi that we're going to connect to. Let me just grab that from this dialog. So that's our IP address of the Modbus device we want to connect to. And then we have the port number. Remember, we set that to 58,000 on that OAS engine running on the Raspberry Pi. And then here's where we're going to enable the failover. It's very simple to implement on all the different driver interfaces. You just enable this property, enable failover, and then you'll see the additional properties that are unique for each particular driver. In this case, if it's a Modbus master connecting to a slave device, I have the failover IP address. I just want it to be my local emulator on my local system. So this could, you notice you can also change the failover port to be something different than the master as well. In this case, it'll be 502 as a default for Modbus. So we are ready to add that driver. A few more things before I do that step. The return to online, that setting is how frequently the system is going to check if both are in failure, both the primary and the backup are in failure, how often it will check again to see if it can put one back online. Now, it will stick with whichever one does have good communications. So if it switches from the primary to the backup, it'll stay on the backup until the backup fails to then switch back to the primary. So let's change this so we can see something kind of a little bit faster at 10 seconds. And also the number of retries. Let me just crank that down to 1 so we have a quick failover. And the number of bad messages to offline to 1 so we quickly go into failure mode. Now all we need is simply a tag to monitor from that Raspberry Pi device. So let's just add a group that we can see, organize some tags in. I'll select that group and add a tag. We'll call it HR1, the same as we called on the Raspberry Pi. It doesn't have to be the same tag name. It can be completely different, of course. And of course, tags can be set up programmatically and also using CSV import and export. So here I'm just doing it manually so you can see how it's done just one at a time. But of course, when you're setting up thousands of tags, it's easier to do CSV import and export using Excel or, of course, .NET or REST interface for a programmatic setup. So here we're going to go back to a data source of Modbus. This time we're going to be a master talking to a slave device. I'm going to set the polling rate here to 0.1 seconds so we can see that fast update from the Raspberry Pi of that data being emulated. So when we select apply changes, we see that value coming in from the Raspberry Pi. Well, that's all pretty simple, but now we have the emulator that we have, and its current value is 123. So what I'm going to do is I am now going to disconnect the Ethernet cable from the Raspberry Pi to cause a failover. So we notice we have a system error after we failed over, and if we look at that system error, the history of it, it has been now resolved, but we saw that we had a communication failure on the primary node of the Raspberry Pi. Now, of course, I can write to that emulator, 456, and we see that value update in the emulator itself. Let me plug my Raspberry Pi device back in so we have it back online. We can check that back using configure tags here just to see if it is back online. It is indeed online. So now what I'm ready to do is to emulate the failover back to the Raspberry Pi. So what I'm going to do is I'm going to stop the emulator. We see the bad data quality from the emulator, and now we have the good quality coming back in from the Raspberry Pi immediately. If you'd like to see another video on how to set up the Modbus interface in more detail, or to follow a Getting Started section under our knowledge base, visit the website openautomationsoftware.com, and at the right, select Support and Knowledge Base. On the left, what we're going to do is we're going to expand data sources or our driver interfaces, and we're going to go down to the Modbus section, and there's where we can see we can set up either a Modbus master or a Modbus slave. We've done both in this video. And there you can see another setup video in a little bit more detail, walking through how to set up a Modbus driver. This is all of the steps that we went through to setting that, and a little bit more as well. If you have any questions, feel free to email us to support@oasiot.com, and we'll be happy to answer any of your inquiries that you might have about the things that you've seen in this video, or of course any thing that you're setting up yourself.